Hello students, in the second part of the video on the classical theory of income and employment determination, we will be discussing the graphical representation of the classical model, and we will also discuss what we mean by classical dichotomy. Let us recollect what we have learned in the previous video. The classical model can be represented by a set of 5 equations as shown in this slide. Equation 1 shows us the aggregate production function where the level of output y is shown to be a function of the level of employment n. The second equation is the labor demand function where labor demand is a function of the real wage rate W by P, and it is a decreasing function of the real wage rate. Equation 3 shows us the labor supply function where labor supply is shown to be a positive function of real wage rate W by P. Equation 4 shows us the labor market equilibrium, and equation 5 shows us the money market equilibrium. Let us move on to the graphical representation of the classical model. For this, we will consider first the aggregate production function. As we know, the aggregate production function shows us the relation between the level of output and the level of employment. So, on the horizontal axis, we measure the level of employment N, and on the vertical axis, we measure the level of output Y. This is our production function, Y equals to Yn. It is a curve which is concave to the horizontal axis, reflecting the law of diminishing returns to labor. We next move on to the labor market equilibrium, where we show the labor demand and labor supply curves. So again, on the horizontal axis, we measure the level of employment N, and on the vertical axis, we measure the level of real wage rate W by P. This is our labor demand function, showing that labor demand is a decreasing function of the real wage rate. This is the labor supply function, showing that labor supply is a positive function of the real wage rate. The two curves are intersecting, showing the labor market equilibrium. We now move on to the quantity theory equation. The equation M equals to LPY may now be represented in this diagram, and through this equation we can show the relationship between money supply M and the level of money income PY. So on the horizontal axis we measure money supply M, and on the vertical axis we measure money income PY. We draw a diagonal line LPY at a slope of 1 by L. From this we can find out the relationship between the level of money supply and the level of money income. We now move on to the wage adjustment diagram, where we show the relationship between the price level P and the money wage W. So for this again we draw the price level on the horizontal axis, and on the vertical axis we show money wage W. We draw a diagonal line inclined at a slope of W by P, and through this line we measure the relationship between W and P. We will now be showing the graphical representation of the classical model. For this, we have drawn all the figures together and labeled them as A, B, C and D. A shows us the production function, B shows us the labor market equilibrium, C shows us the quantity theory equation, and D shows us the money wage adjustment. Now for the solution of the classical model, we start with the labor market equilibrium. So we will start with part B, where we show the intersection between the labor demand and labor supply curves. This intersection, from this intersection, we can determine the equilibrium level of employment, that is level N0, as we can see over here. And we can also determine the equilibrium level of real wage rate W by P0. Now, from this level of employment, we can also determine the level of output from part A, where again we take the level of employment to be N0 and the level of output as Y0, which can be read off from the production function diagram. The question that arises now is, what is the guarantee that Y0 output will be demanded? Because if Y0 output is not demanded, then N naught labor will also not be employed and the system will collapse. But we know that classicals believed in the Say's law of markets, which says that supply creates its own demand. That means whatever is produced will automatically be demanded. That is, there will be no problem of deficiency of demand. So Y naught output will be demanded and N naught labor will be employed. So the system works. Now let us move on to part C, where we have shown the quantity theory equation, and through that we will show the relationship between M and Py. In the classical model, we take money supply to be exogenously given. So here we take, suppose, money supply to be M naught. From this we can determine the amount of money income, that is Py naught. That is the amount of money income which this M naught money supply is supporting. Since the value of Y naught is already determined in part A, from this part C we can easily determine the equilibrium price level, that is P naught. Now moving to part D, we can see now the relationship between price level and money wage W through this line. Since the price level has been determined in part C, so that is, we will take this as given, that is P naught, and from this line we will now determine the equilibrium value of money wage, that is W naught. So we can see from parts A and B we have determined the equilibrium value of employment N naught, equilibrium real output Y naught, and equilibrium real wage W by P naught. And from part C and D we have determined the equilibrium level of price, that is P naught, and the equilibrium money wage W naught. This is the graphical solution of the classical model. Let us now see what we mean by classical dichotomy. The classical model is a dichotomized model. This means that it is possible to divide the classical model into two parts, the real part and the monetary part. And the equilibrium values of the real variables get determined in the real part, and the equilibrium values of the monetary variables are determined in the monetary part. Changes in the real part can affect monetary variables, but changes on the monetary side have no effect on real magnitudes. To explain classical dichotomy, we consider the previous diagram, where we can see now parts A and B comprise the real part of the model and parts C and D comprise the monetary part of the model. As we have seen previously, from part A and B we have determined the equilibrium level of employment N naught, equilibrium real output Y naught, and equilibrium real wage W by P naught. These are the real variables. And from part C and D we have determined the equilibrium price level P naught and the equilibrium money wage W naught. These are the monetary variables. So this is what we mean by classical dichotomy.